The key to all algebra used for science is a tool called inverse operations. And what that basically means is that whenever there's a constant or a variable that is moved to the opposite side of the equation that it finds itself on originally, then the operation inverses. What we mean more specifically is that if something is multiplied on one side, and I'll do a star for multiplying because sometimes the multiplication symbol and an X get confused, then when we go to the other side, it becomes a division. When something is added on one side, when it's brought to the other side, it becomes subtracted. Another common category of inverse operations or reverse operations is when we have roots and exponents. And so if we want to remove a root and we bring it to the other side, we just simply exponentiate that variable or the constant. At the same time, if we have an exponent and we want to remove that exponent, then we can root it and that's going to remove that exponent. So this is another key inverse operation as well. So we'll begin with some one-step algebra problems here, and we're going to isolate for x. So in the first one here, 2x is equal to 3. Since it's 2 times x, I'm going to divide both sides by 2, and that's to get rid of the 2. And we're doing that because it's multiplied by 2, so the inverse is division. And so we get x is equal to 3 over 2. Now, if I go to the next one, I have x minus 2 is equal to 5. Now the inverse operation is addition. So we're going to add 2 to both sides. That would cancel the 2's on the left side, and then x would be equal to 7. And again, both different cases of inverse operations. Now, when it comes to two-step algebra problems, I would make one move at a time and isolate one variable at a time independent of the other, and then simplify when you can. Let's take a look at this in action with the next examples. In the first one, 2x minus 2 is equal to 10. I'm going to get rid of the 2 first by using inverse operations. That means I'm going to add 2 on both sides. Now that still leaves me with 2x on the left side, and that's okay. So when we rewrite this, it'll be 2x is equal to 12. Now, as a second step, I'm going to isolate the x by removing the 2. And again, using inverse operations, since it's multiplied, I'm going to divide both sides by 2. And that's going to leave me with x is equal to 6. So I had to do this one in 2 steps. Now, for the next one, I'm going to do the same thing, even though it looks a little scarier because we got a fraction right beside the x. I'm going to remove the 3 by subtracting on both sides here. And I'm subtracting because it's added on the left side, so that'll be minus 3 on both sides. That cancels the 3 out on one side. And then it'll be half x is equal to 9. Now, in this next step, some people get a little bit intimidated when it comes to a fraction. So what I do is, whatever the number on the denominator is, I multiply both sides by that, because that gets rid of the number on the denominator. So in this case, it's 2. The 2's cancel out, leaving one x or just x. And of course, I multiply the 2 on the other side. That would leave us just with x is equal to 18. Okay, now I know this one might be a little bit unusual. If it was 1/3 x, I would have multiplied both sides by 3. Or if it's 1/4, I would have multiplied both sides by 4. Now, another way that this can be done is you can just go right ahead to dividing both sides by half. And that's because it's really half times x. And that'll give you the same answer, right? Your halves on one side will cancel. And then 9 divided by a half is also 18. Both of these ways are okay. You just do whatever is most comfortable for you. This next part here might get people a little bit started because there's 3 terms now. So I'm going to remove the 4, again, one term at a time. And that'll leave me with 2x plus 3x, and that's going to be equal to 16, okay? And again, the more terms there are, the more steps there's going to be. Now what I'm going to do is I can gather like terms, and that's going to be my second step. So 2x plus 3x is going to be equal to 5x. And then when I rewrite this, this will be 5x is equal to 16. Now, I'm going to do my final step, which is inverse operations to remove the 5. So since it's 5 times x, I'm going to divide both sides by 5. That'll cancel the 5s on the left side. And then my final x is a fraction, 16 over 5. And I can't simplify this any further, so we're just going to leave it like that.